So I have completed all the 9 columns here, taking up from the previous slide here. So here 1 to 2, 1 to 3, and so on and so forth. So if you observe in the diagram, network diagram, the critical path is 1 to 3, 3 to 5, and 5 to 7. So the independent float, if you see for 1 to 3, 3 to 5, and 5 to 7, they will be 0. So this is how we calculate the floats. While computing the floats, you need to take care of one thing, is that if the independent floats are given, are worked out to be negative, then such negative values are taken to be 0. So this is about this problem. Now let us go to the next concept, which is PERT. So here under the PERT, that is Project Evaluation Review Technique, types of time estimates under PERT network. There are 3 types of time estimate. One is optimistic time, which is indicated by T0, then TO, pessimistic time estimate, which is TP, most likely time estimate, which is TM. So T0 is that is the shortest possible time required for the completion of an activity when all the conditions are extremely good. So here we are taking up 3 conditions. One is good, the other one is bad, and the normal. So TP is where the conditions are bad, and TM is where we have normal conditions. So it's a maximum possible time the activity take all the when all the conditions are bad. So TM is the time required of an activity which takes executed under the normal conditions. So we are given the formula here to compute. TE is a time, expected time, is equal to T0 plus 4Tm plus TP divided by 6. Standard deviation is equal to TP minus T0 divided by 6. So this is what is the formula to compute the mean time and the standard deviation. So coming down to the first problem under the PERT. So the following table shows the job of network along with their time estimates. So we are given the three times, that is TO, TM, TP. So jobs are also given. So here we have to calculate the standard normal variate, and we are to also calculate the mean time and the standard deviation. So for to compute here, now let us, first thing that we have to do is we have to list down all the activities. Then the expected time is equal to T0 plus 4Tm plus TP divided by 6. Standard deviation is equal to TP minus T0 divided by 6. So here if observe, it is very much given to you in the problem. So T0 is for the first activity 3 plus 4 into 6 plus 15 divided by 6, which works out to 7 days. Then the standard deviation is equal to TP, that is 15 minus 3 divided by 6, which works out to 2. If you take the square of the same, it works out to 4. Now 1 to 6 is 2. T0 is 2 here. Then plus TM is 5. 4 into 5 plus 14 divided by 6. So that works out to 6. Then 14 minus 2. So this is TP minus T0 divided by 6, which is equal to 2. If you take the square of the same, it works out to 4. Then 2 to 3. So 2 to 3 we have the T0 to be 6 plus 4Tm is 4 into 12 plus 30 divided by 6, which is equal to 40. Then TP minus T0, 30 minus 6 divided by 6, which works out to 4. 4 square is 16. Likewise, we will have to calculate for the 2 to 4. So 2 to 4, it is given as 2 plus 4Tm, 4 into 5 plus 8 divided by 6, which is equal to 5. So here TP minus T0 is 8 minus 2 divided by 6, which is equal to 1. Squaring up 1, we get 1. So here 3 to 5. So 3 to 5 is given as 5, 11 and 17. So 5 plus 4 into 11 plus 17 divided by 6, which is equal to 11. So 17 minus 5, which is divided by 6, is equal to 2. Square it up, we get 4. So likewise 4 to 5, we have 3 plus 4 into 6 plus 15 divided by 6, which is equal to 7. 15 minus 3, TP is 15 and minus 3, which is equal to 12 divided by 6, which is equal to 2. So if we square it up, we get 4. So likewise for 5 to 8, it is 1 plus 4 into 4 plus 7 divided by 6 is equal to 4. 7 minus 1 divided by 6 is equal to 1. Square it up, we get 1 again. 6 to 7, 3 plus 4 into 9 plus 27 divided by 6, which is equal to 11. So 27, TP is 27 minus 3 divided by 6, which is equal to 4. 4 square we get it as 16. So likewise we have calculated for the 7th event also. Now let us work out the network diagram for this particular problem. So if I draw the network diagram, it will be, so you are given the jobs to be like this: 1 to 2, then 1 to 6, correct, then 2 to 3, then 2 to 4, 3 to 5, 4 to 5, 5 to 8, then 6 to 7, 7 to 8. So the duration is 7 here. 1 to 2 we have the estimated time to be calculated as 7. So whatever is calculated here, estimated time, we make a note. So for 1 to 6 it is 6, right? So 2 to 3 it is 14, then 2 to 4 it is 5, then 3 to 5 it is 11, then 4 to 5 it is 7, then 5 to 8 it is 4, 6 to 7 it is 11, then 7 to 8 it is 18, sorry. So again what we need to do is, after calculating this, we have to work out all the possible paths here. So 1 to 2, 2 to 3, 3 to 5 and 5 to 8, 1 to 2, 2 to 4, 4 to 5 and 5 to 8, 1 to 6, 6 to 7 and 7 to 8. So if you observe here, we have calculated the duration for all the possible paths. 1 to 2, 2 to 3, 3 to 5, 5 to 8 has got 36 days. So this is the critical path, which is the longest path in the network diagram. So that is indicated with the double lines. So what we do is, we have to take the activities in the critical path, make a list. So 1 to 2, 2 to 3, 3 to 5 and 5 to 8. So we have to make a note of the variances that we have calculated here. So 4, 16, 4 and 1. So that works out to 25. So if you take up the standard deviations, this is variance is standard deviation square is equal to 25. Is it not? So sorry, 25. So standard deviation is equal to square root of 25, which is equal to 5. So now standard normal variate we can explain with the formula, that is z is equal to x minus mu divided by standard deviation. X is the variable which is unknown, so it varies. So minus 36 is the total duration that we have for the critical path, divided by the standard deviation value is 5. So this is how we calculate the standard normal variate.